Hello, in this video I'm going to explain or answer these two questions. How do transverse waves differ from longitudinal waves? And consider a wave traveling on a taut rope. What is the difference, if any, between the speed of the wave and the speed of a small segment of the rope? The answer number one is transverse waves work by going up and down. If you think of ripples in the water, they come out like this. If you drop something. And then if you look closely, you'll see the wave actually cresting, and there's a trough. And transverse waves differ from longitudinal waves by the fact that they have this crest and trough movement. They are the wave is formed perpendicular to the direction of motion. So if you look at a drop of water, it spreads outward, but the wave is always coming up or down into the water. They aren't, and then they move out that way. For longitudinal waves, if you just clap your hands, you'll compress the air. If we have let's say we have a wave going this way, it'll be an air compression, and each one of these air compressions coming out is in the direction of motion, and they don't exactly work like this over here. They work as compressions, and you can get a wave function out of it because you get the high probability or high density of air particles, the low density of air particles. And so when you're graphing it, you can still get this wave type function, but in actuality, it's just particles put together. For the next part, what I'm going to say is if we have a taut rope right here, and we wiggle it real quick, we'll have this wave function, or this wave in orange going down here. There's no actual, this rope will have a net displacement of 0. Well, I should do that in orange. The rope will have a net displacement of 0. But the wave will go all the way down. Say this is attached to a wall. It'll hit this wall and then bounce back. And if this was the rope, you can try it. And the speed of a small segment of the rope is actually going to be 0, because for the most part, if you just wiggle it once, one crest, one trough, the rope will actually just maintain its tautness. But the wave will go down down and up, causing a displacement over a small segment. But the rope actually has a net displacement of 0. The wave has a net displacement of would have a net displacement of 0 if it came there and back, but going down it'd have a net displacement of, let's say this is 0 to L. It'll have a net displacement of L when it hits this wall, or if it comes back, it'll have a net displacement of 0. But the speed, difference between the speed of the wave will be going at whatever speed it is. The small segment of rope will only have this small displacement if you're looking at it right then, and the net displacement will be 0. And because the wave, if you just go up and down once, is moving down this rope, it'll be your chances of looking at this small segment of rope is relatively small. So you'll actually get the rope is probably not moving at all, and this wave is moving perpendicular to the this wave as a whole will be moving down there and back at a different speed entirely from the rope. I don't know how well I answered that. I'll fix it if need be. Thank you.